Good morning, everyone. I am Manos. I'm a software engineer at Mysten Labs, and I'm part of the DevX team. And I'm mostly guilty of spending most of my time working with Move, which probably means I'm on the right conference. Today's topic is all about packages, where we'll discover some of their characteristics. Then we'll move on to our tooling and what excites us for the future. As you probably understand, this agenda won't reveal a lot more than the title, so I'd better get started. Let's start with packages. Like everything on Sui, packages are objects. Each package is assigned a unique object ID when publishing, and it can be looked up. On the right, we can see a simplistic example of a package I've published on Explorer. We can see that it has an object ID, a version, a publisher, and the modules. So every package can have one or more modules. That way, we can keep our logic separated and keep our code lean and small. The package I will use for this presentation, which is a demo package, contains a single module, which is our hero, as we can see on the image on the right. Moving on, so we have modules. Modules are the logic of our contract. If we look at the example on the right, we can see the module I mentioned before, which is hero. We can start with our imports, then we can define different structs, which are also referenced as types. You might hear me saying that, which have their own fields and abilities. And we can have multiple functions with different visibility. We can have public functions, which any other module or any off-chain usage like PTB calls can call them directly. We have private functions. Private functions are only visible to this module. Even if this package contains more modules, they cannot see it and cannot call it. For that purpose, we have the friend packages right now, where we can define friends and other modules can call our code. And I would like to give you a spoiler here that we will have public package coming up with Move 2024. So I suggest you watch Todd Nowaki's talk tomorrow. So fields on our structs are private to the module. That means that only this module that defines them can access them. If we need to access them outside of the module, we need to define getters and setters with our specified logic. And lastly, these structs are private to the module, and that means that they can only be constructed where they are defined. As I've already mentioned, our package can depend on other packages. That means that we can create single use case packages with lots of code reusability. It's really great because we don't have to publish our code again and again and again. If we go ahead and think of an example, I can create single purpose libraries like text manipulation library, a utils library, a match library, payment management library, and I can build apps reusing them again and again. I gave you a little bit of time to read the slide, but this is clearly an attempt to say that packages are immutable. The moment they're published, they cannot change. Apart from the safety considerations when we're talking about immutability in packages, if we look at the object-centric design of Sui, whenever we have owned objects or immutable objects, we can utilize Sui's fastpath, which is extremely fast and offers sub-second finality. So we can see how that's also connected with those. Packages are upgradable. I mean, it sounds completely the opposite of what I said before about immutability, so I should probably elaborate a little bit further. Each upgrade is a separate package. If I publish package A, I will get version 1. If I want to authorize an upgrade, I will get version 2. Structs, as we said before, that we often refer to as types, remain interoperable between all versions of the package. So that means that the same module on version 1 and version 2 can edit the structs and the fields and can access them. Let's look at some of the default rules we need to follow when we're doing, we have to follow actually, when we're doing package upgrades. First of all, public function signatures cannot change. That means that I cannot add any more object or primitive inputs to a public function. New functions and structs can be added. I can go ahead and add as much functionality as I want to on a package upgrade. Implementation of a public function can change. Even though we said that we cannot change the signatures, we can still change the behavior. We can remove anything that's not public. So that could be constants or private functions. And it's important to note that currently, struct fields cannot change on a package upgrade. And we can say that upgrades in Sui are flexible. We can choose between different policies. If I want to, I can make my package completely immutable. That means that this package can never be upgraded. So if I decide to make it completely mutable on version 1, I can never have a version 2. For the upgradable packages, I can also choose the flexibility I want to give out there. We can have dependency only package upgrades. That means that we can only modify the dependency of a package. We can have the additive policy. That means that I can only add new functionality, but I cannot change the existing implementations for a public function, for instance. And we have the compatible mode, which is the one we discussed before. It's the most flexible and default approach. And due to the nature of packages, we can also define custom upgrade policies. Let me actually give you an example of why we built a custom policy. We can imagine that applications that manage assets have important requirements in terms of security. Let's say that a DeFi protocol is exposed to these requirements because they can manage significant amount of tokens or coins. The users that use this protocol require some level of guarantee in regards to the upgradability. First, as engineers, we cannot assume that we will always have error-free code, and in most cases, we will need to evolve our code. At the same time, users expect a level of protection around decisions made on package upgrades. And that's why we ended up creating the quorum upgrade, which is a K out of N policy where multiple people can vote for a proposed upgrade. And only when reaching quorum, the upgrade can go through. I actually suggest you go through and read more on the QR. Let's talk a little bit about the dependencies and the upgrades. If we have package A on version 1 and we have package B on version 1, where B depends on A, then sometime later we decide to upgrade package A to a version 2. You could easily be confused and think that package B would directly depend on the version 2 of package A, which of course isn't true because we discussed already about the immutability. A user needs to explicitly update their package in order for package updates to take effect. And one thing I also want to point out here is that previous versions of our package are still callable. That's already clear from the previous example, but it's always good to remember that when upgrading, we can still call previous versions. It's easy to forget it, and that's something to point out. However, there are some design patterns out there that we can actually make version-gated access to our modules, but I will not expand any further on that on this talk. So if we have some key takeaways here, packages are safe because the risk of calling them does not increase over time. So there are some assurances on the safety. Our packages are modular and reusable. We can keep our packages lean and small and reuse them across our apps. Our packages are upgradable, as we discussed before. And one last note I want to give out is that our packages are composable. One nice example about that is Sui Friends. Sui Friends is a project with copies, as you probably have seen it. And Sui Friends has been used by many different packages to drive quests or voting systems. And we also used it to give special discounts on Sui NS, which is a completely different app. And that shows the nice composability of our network. Now we'll move on to some tooling and what's coming up in the future, what excites us. Let's talk a little bit about source verification and discovery. We can understand that there are many reasons why we want to verify source code and actually see source code. First of all, we want to review the code we're calling, at least if we're not fairly decent at understanding bytecode, and I doubt not many people would be. We want to explore move code and potentially use it as a dependency on our packages. That's another reason why we would want it. Or we also might want to verify that the bytecode that's on chain corresponds to the code we see. For these reasons, we built an open source validation service which allows us to view verified source code for a published package, as long as it's submitted on the list. For AI, Mysten Labs also maintains an active API that verifies the source code for a list of known packages, so feel free to submit yours as well. And going ahead and seeing the verified source code in action, we can clearly see on the screen that it's a little bit harder to understand the code by looking at the bytecode, but it could just be me, so please ignore this comment. I'll continue with my assumption. And here we can see that with the verified source code, we can read and understand what's going on with the package we're using, or we want to call, or we want to analyze. Now, next, I will talk about automated address management. I think that any of you have already maintained the package across networks, and especially when introducing package upgrades, will immediately understand the value proposition of this. Let me try to explain the situation as much as I can. In today's world, in order to do a package upgrade, I have to open the manifest file. This is an example you can see on the screen. It's the move.toml file, and I will have to go into the addresses section, change the address to 0x0, run the transaction to do the upgrade, and then collect the addresses from the results and go ahead and update the appropriate fields on the move.toml file. Well, we understand that this is too much of a manual flow, so this is where automated address management will come to the rescue. We'll be able to automate away the manual work required after a package publish or upgrade, and it will also take care of versioning for us. It will help us manage our packages across different networks, and finally working with them will be a breeze from now on. So I'm super excited about that. Now let's talk about on-chain dependencies and what it means. Today, in order to depend on a package, we have to have access to the source code. Even though it's generally encouraged to open source code in Web3, we cannot expect all packages to be open source, and we cannot expect to know where the code is open source. And something exciting here that's coming in the upcoming months is that we will be able to depend on packages directly from the chain. That means that we will be able to compile against them, and we will no longer need to access the source code. This is a great initiative from K-Class, and I encourage you to scan the QR code to learn more about it. It's extremely exciting, and it's also a great showcase of the endless possibilities open source contributions can unlock. So the last topic I want to discuss today is the .move service. This is a project I'm highly involved with, and I get really excited thinking how it will shape out in the upcoming months. Let me give you a little bit of a background for the .move service. .move service will be offered from Sui Network. For those of you that haven't heard of it, it's our naming service. If you're curious what that is, it allows us to use friendly domain names instead of addresses. I mean, even if you open up an Explorer right now, you can also look me up, like using manos.sui. It's super easy. And now you can use manos.sui to send assets to me instead of using my address, which is a little bit hard to remember. And based on that, that's something similar we want to accomplish for packages. I mean, looking at this address, which is the SuiNS mainnet address, I can try to spell it out loud, but you'll probably stop listening to my presentations, and that's something I don't want. So looking at it, I can say that it's hard to remember, and we understand that it's becoming harder and harder to look it up. It's easy to confuse it with another. I mean, I hope you understand. I hope it's also visible for you as well and clear. It's hard to validate, and I would say it's harder, especially for non-super technical users. And I would overall say that it's a bad user experience, at least in my view. And our overall goal is to increase adoption to the masses. So it looks like a gap here. Now let's look at our vision. I can proudly say out loud it's suiNS.mystenlabs.move. Looking at it, I can say that it's easy to remember. It's, I believe, way harder to confuse it with another one. It's easy to validate, and I believe, and I hope you all agree with me, that it offers an even better user experience. And going further from that, we can also imagine the endless possibilities, like we can combine it with on-chain compilation, and now I can depend on a package by just specifying the .move service name, suiNS.mystenlabs.move. I can combine it with source discovery, so I can go into any explorer, type the package, and I can see the source code as long as it's there. And we can also imagine, we can even let our imagination go even further and imagine things that are getting unlocked, like we could have directories of packages that with the above points combined, we can browse packages and use them as we're building our apps. So as I'm closing this out, I would like to say that the vision for .move service is combining all the different tools that are coming up or are there already with a better UX. And looking at this plan, it's clear, at least to me, that adoption can be brought to the masses with safety and usability, and it can scale to billions of users. I will close this up with Sui's tagline: Sui delivers the benefits of Web3 with the ease of Web2. We are committed to continue innovating in the industry while creating a great environment for engineers building on the network and users using these apps. That's it. Thank you. If you have any questions, feel free to reach out on Telegram, my email.
Okay, thank you. Thank you, Manos. Thank you for sharing.